billion-dollar chip fab can stop even when its most expensive tools are ready. The Semiconductor Industry Association says chip fabrication can require as many as 300 inputs, from raw wafers and commodity chemicals to specialty chemicals and bulk gases. That is an industry estimate, not a universal parts list. But the operating logic is clear. Every required input must arrive in the approved form. One missing gas or ultra-pure liquid can interrupt a process, because chemical availability does not make an untested substitute acceptable. NIST says high-purity source materials must be qualified by overall purity and by priority contaminants. It also says current characterization methods and reference materials still leave important gaps. That matters because the product is not merely a molecular formula. It is a controlled impurity profile, repeatable lot after lot, inside compatible packaging, delivered without introducing particles or trace contamination. In this business, analytical proof, filtration, container cleaning, transport, and traceability are part of the material. A cheaper formula can be useless if its measured behavior is not stable. SIA divides fab chemicals into 3 practical tiers. Bulk chemicals are purified for semiconductor requirements and may arrive by tanker or tote. An intermediate tier has demanding specifications, but generally more than one supplier. Ultra-specialty chemicals may be consumed only in liters or milliliters per batch, yet can represent disproportionate spending because the required performance, purity, and specification are difficult to achieve. Fabs run around the clock and need all 3 tiers simultaneously. Plenty of bulk acid cannot replace one missing specialty input at a critical process step. SIA testified that semiconductor tools are often designed around specific chemicals and that many chemicals typically have no drop-in replacement once implemented. That is an industry statement, and it does not apply to every chemical. The narrower point is still powerful. A proposed alternative must be validated against the process, tool behavior, yield, reliability, safety, emissions, and change control rules that matter for that use. Do not assume a universal qualification time. The bottleneck is the evidence required before the fab can trust a new material in production. Inside the fab, delivery is part of the specification. SIA describes enclosed automated systems that deliver exact quantities at the right place and time. Bulk materials can require dedicated tanks, double containment, specialized piping, gas cabinets, monitoring, and waste treatment. The fab runs 24 hours a day, so continuity and safe control are operating requirements, not optional accessories. This is why a material supplier competes through more than a factory gate. Packaging, on-site handling, alarm response, logistics, and documentation all sit between a chemical plant and a finished wafer. That physical system creates a continuous invoice. Chemicals, gases, filters, containers, analysis, and abatement are consumed or serviced as wafer production continues. The economic inference is straightforward. Recurring exposure grows with production activity, while the consequence of inconsistency can reach work already in process. But scarcity alone does not guarantee pricing power or investor returns. Customers are concentrated, capacity is expensive, and environmental and safety obligations are real. The useful questions are whether the material is technically differentiated, how much qualification protects the relationship, and whether capacity is actually utilized. A supplier's own filing can reveal where exposure sits, but only for that company. Entegris says its portfolio includes deposition materials, specialty gases, etch and clean materials, filtration, purification, and contamination control. Its 2025 annual report also says some membranes, resins, engineered abrasives, and specialty or commodity chemicals come from single, limited, or country-specific sources. It uses multi-year supply agreements to improve assurance and control cost. That does not prove the whole industry is single source. It shows the exact sourcing disclosures investors should look for. Finding an alternative is an engineering program, not a synonym swap. In June 2026, The U.S. Commerce Department announced a $500 million CHIPS Research Award to Sandbox AQ for materials discovery work, including PFAS alternatives, high-purity catalysts, rare earth-free magnets, and backup power chemistries. The award is not proof that every fab faces an immediate shortage, and it is not an endorsement of any supplier. It is evidence that material substitution can require measurement, modeling, synthesis, testing, and process validation before a candidate becomes useful at industrial scale. To audit a tiny bottleneck, start with the process step. What function does the material perform and what impurity limits matter? Is supply broad, limited, or only company-specific in the evidence you have? Which tool and delivery system are tied to it? What test, customer approval, safety review, and change control would an alternative need? How much inventory is practical and where is it held? Finally, separate three different claims. A material is scarce, a supplier has capacity, and a supplier can earn attractive returns. They are not the same conclusion. The fab is an ecosystem of tools, materials, containers, pipes, filters, tests, and approvals. The visible machine gets the headline. Purity and continuity determine whether that machine can run the intended process. Follow the qualification file from raw input to finished wafer. Who makes it? Who measures it, how it travels, where it is stored, which tool consumes it, and what happens when anything changes. That is where a tiny bottle becomes strategic. Circuit and ledger follows the technology and the money behind it.